GIS-processes, part 2. We're almost there, 2 more weeks. And today we are going to talk about visualization, something I've been promising already from week 1. We have already made some basic maps here and there, just to see what is the output or what is the data we are working with. But today we are getting a little bit deeper into visualization. So our lesson has only 2 parts, but they're a bit bigger. In the first part, we will work with a static map. So we just learn how to generate a static map, export it as an image file, for example. And in the second part, we learn how to make interactive web maps, so it can interact with the map in different ways. So that's the idea of the lesson today. And as we know, a big part of GIS is producing a map. It's not always the case, but very often we have some sort of map, and we are doing geospatial analysis. So it's an important part of this course, maybe. But before we continue with the actual materials of today, I would like to remind you of a few things. One thing is that this course is a bit like technical. So like the point is to learn how to make the maps. So we do not really focus much on how to make beautiful maps. So if cartography is something that you're interested in, and you should be because it's an important part of geography, GIS, then we have another course which I mentioned already in the first lecture, Cartographic Visualization in GIS, which is an intensive course, just 4 weeks in May, running every year. And it has similar format as this course. So if you don't want to take the course officially, the materials are still open, so you can check out. So the course is implemented like in 2 tracks, parallel. So one is in QGIS, and then you learn to make the exact same map in Python. So it's a good continuation for this course. So in that course, we get it, that's a cartography course. So we get into details of how to really customize the maps. Now we just learn, okay, this is how you make a legend, you put it here or there, that's it. But in that course, we really learn how to customize things. And it's an open course, so you can check out the materials if you're interested. And also we get into more like the aesthetic elements of making a map, so how to make a beautiful, proper map. But today is more about like writing the right code and producing the map. And of course, we will practice how to make better map. So that's a big part of, so that's one thing about the lesson today. The second thing is about documentation. I've been saying many times during this course that when you're programming, when you're working with these different libraries, the documentation of that library is your best friend. Because you cannot remember everything by heart unless you're using the same library for all your life every day. Yeah, then you might eventually remember things. But it's especially true for libraries that are related to visualization because there are so many parameters, so many elements how to like move one item from here to there or change a color. So there's no way you can remember everything. So if you're doing your exercises, if you're doing this and you don't remember how to change certain things, it's quite normal. So it's common to like refer to run resource, check the documentation to see how to do things. But knowing how things work will help you produce maps more effectively. So that's another thing. Check out the documentations. So another thing that very often comes up in this course, or especially in the cartography course, which I also teach, is why would we make maps in Python? Because we haven't started yet, but I imagine you know what to expect. You don't have this beautiful user interface like you have in many software. You can just drag things, copy and paste, like do things easily. So what motivates us to even learn how to make a map in Python or any programming language in the first place? Do you have any idea? What would be the use cases for you that you would choose Python over QGIS or ArcGIS or whatever software you're used to? Any ideas?
I think it's kind of easy to make multiple maps once you have your own template created.
Yeah, very good point. Anything else?
No, you're the only one who's in control. So if something goes wrong, you know that's your fault.
Yeah, exactly. Anything else? Yeah, so those are important things. So one thing you mentioned is the reproducibility. So if you have made a map and you have to produce the map again, you have the code, so it's kind of easy. And also you're in charge of things. Of course, now the modern versions of the software we use for GIS are quite good at producing different maps and like changing things, but it's still, you're limited by what the developer has imagined you find necessary. So if there's something very special or unique that you want to do with your map, in the software you have limitations. But with programming, of course, you will be challenged if you want to do something difficult, but almost there is no limitation. If you are good enough at programming, you can just do whatever. So if you do things in Python, you have more flexibility how you want your map to look like. Another important thing, which is also in the name of this course, is automation. So it depends on what you're doing. Sometimes you just produce one map, and that's it. And it might be just easier to do it in QGIS or somewhere else. But sometimes you want to automate the process because you need to produce that map frequently, or there are a number of maps you need to produce at the same time. Like, I don't know if you have seen, there are like, nowadays it's a bit fashionable to have maps as like posters on the wall. I've seen in people's homes. And there are businesses that sell these maps. You can just get a poster of Helsinki map or something. I don't think there is anyone really sitting there at QGIS or ArcGIS printing those maps. Probably it's an automated process. You just say, I want a map of Helsinki. It has some base maps from, I don't know, Mapbox, OSM somewhere, and it just prints the poster for you. Or you might have a job, and in the job your task might be to produce individual maps of all postal areas in Helsinki or all major cities in Finland. So doing this manually takes forever, but also you may not be very consistent with the zoom level and the style and everything because you're producing the map many times. But if you automate the process with Python, then you can produce almost identical maps in any case. So these are some of the motivations. Another major motivation for people to use Python or programming languages for visualization is this one, the interactive maps. So there are like plugins in QGIS that allow you to do some kind of interactive map, or in ArcGIS you're limited to this online ArcGIS or something like that, ArcGIS Online. So yeah, so you're limited by what is offered. But when it comes to programming, if you're comfortable with like Python and especially like web programming, then you can just make any kind of interactive map. So that's also something we are learning today. So the learning goals for today. So we will learn how to make thematic maps. So we will start with static maps, then we will continue with interactive maps. We will continue working with GeoPandas that we are very familiar with, and Matplotlib, something we learned to work with already during this course and in the last period. We will learn also how to add base maps. That's something we haven't done yet. So you will see how you can add base maps to your maps in Python. And for that, we will learn to work with a new library called Contextily. So we will use that for adding base maps. Then we will create our interactive map. And for that, we use, again, a new library called Folium, which is a powerful library for creating interactive maps, but it's not the only one. There are many more. And then we will also continue working with the interactive map, adding some features. So we will learn how to add, for example, pop-ups to your map, or adding this kind of tooltip. So if you hover over the features, you get some message shown. So that's the agenda for today. Let's start. I already pulled the changes. If you haven't done so already, please do now. And once you open the folder, you will see two notebooks. Let's start with the static map. So I guess it doesn't need any definition. You know what I mean by a static map. And we have already produced maps simply by using geodataFrame.plot, which uses Matplotlib under the hood. So now we are going to continue working with that, just add more elements and customize the maps a bit further. So the data we are going to work with for our visualization in this first part is the same data as last week. So it's the Helsinki region travel times, all the travel times to the Helsinki Central Railway Station. So that's the data we are working with, and it's already saved in our data directory. So let's start by defining the path to our directory. Yeah. So in this exercise, like something we haven't done so much before is like we're adding more layers to our map. So we have the matrix, the travel time matrix, but we are also adding two other layers. One is the metro network of Helsinki, and the other one is a simplified network of the major roads in Helsinki area. And we are getting both these data sets from WFS of Helsinki map services, so we don't explicitly download anything. So let's just run this cell. This is the code we need for importing the data, both of them, the road network and the metro lines. So one thing I've added to this code, I haven't tried it recently to see if it works without this. At least previously when I was using this, there was something with the Helsinki info share where you get the data from, and it had some problem with the SSL certificate. So it was a like security thing, but since we trust Helsinki info share, so I've just added this exception to proceed even if there is problem with certificate. So that's why we have this line SSL related to SSL certificate. So normally if you don't run that into that error, you don't need these two lines. You don't need to import SSL, and you don't need this. So that's why we have this line. The rest is just a basic WFS URL, which we have seen before, and then just loading the data sets. So one thing I've said many times during this course, and I'm going to remind you again, is the coordinate system. When you are plotting things, again, you are not in a software environment. So if you have your layers, well, if you have just one layer in your map, it's all right, whatever coordinate system it is in. Of course, it affects, you should choose the proper one because it affects how your map looks, depending on the projection system you're using. But it is mostly a problem if you have multiple layers. So if they are in different coordinate systems, then they do not appear in the same place. So make sure they're in the same coordinate system. We are doing that here with this assertion line. So let's check if our coordinate systems are in the same CRS, and that is not the case. We get an assertion error. So I've already typed in the code here, so we don't have to type. Let's just run them. The roads comes in 3879 coordinate system. The accessibility grid is in 3067, which is this transverse Mercator in Helsinki that we often use. And the metro is also in 3879. So the data sets we got through WFS are in a different coordinate system compared to matrix. Yeah.
Question to the WFS import. We set the CRS manually here, right?
Yeah.
So can you set it to any CRS which is handy and it will reproject correctly, or do I have to set it to the one which was specified on the website?
It is recommended to use the one that is specified in the documentation. So even if you don't put this there, it will work. But yeah, I'm more comfortable doing it outside to make sure everything goes well.
So could I just say set CRS to like Mercator or WGS84, whatever?
Here,
Yeah.
probably will not work. I guess what set CRS does is it doesn't project.
Yeah.
It just defines. So it tells you that it tells the GeoPandas that this data is coming in this CRS. Yeah, this is what it's doing. So that's why we need these two CRS to convert it. Yeah. Yeah, so if you just put something else, it just gets confused because it doesn't match the real coordinates. Yeah. But yeah, so these are in different coordinate systems. So what we are going to do is to continue with this 3067 that we are most comfortable with in Helsinki area in Finland. And we project these two other data sets, the roads and metro network, to the same CRS. So now if we run this assertion again, we should not get any errors, which is good. Okay, so now that our data is ready, they're in the same coordinate system. Now we can continue with our visualization. Okay. So before I start doing this, take a few minutes and try to plot this however you remember. We have done this a few times during the last few weeks. So try to make a map and start with just a simple dot plot and then add more layers, change the color, see how much you remember, then we do it together. So did anyone manage to produce any map? How many of you managed to add all 3 layers to the map? Continue working like 2 more minutes, then we get back here and go through the code together. Okay, so while you were doing this, I also typed in the code at the same time. So what I'm doing, I'm importing the pyplot from Matplotlib, something we have done before many times, especially in the first period. Then I'm creating my X object based on one of the layers. I'm using the accessibility grid. I provide the figure size, the column I want to use for my visualization. Then this is something we covered last week. Classification, I'm using quantiles to classify the values in this column, and then a color map. So there's a link here to Matplotlib documentation, and you can see, if you just scroll down a bit, you see there is a very long list of color maps you can use. So you can just use the name. So of course there are ways of also customizing this, but this list is so long, probably you will find something that suits your needs. So from here I've just chosen one of them that I know looks okay. So I'm using Spectral, which is, so I guess it's from blue to red. Then line width, I don't want to see the grid lines. It would make the map very crowded and ugly. So I'm applying 0 as the line width to just hide it. And then alpha is something we haven't seen before. When you're adding a layer, you can specify an alpha value, which adjusts the transparency of the layer. So 0 means you won't see it, it's fully transparent, and 1 is not transparent at all. So depending on what you need, it adjusts the level of transparency. And then I'm adding other layers. Of course, I created the X object in the beginning, then I add other layers of specifying a color, line width, and so on. So yeah, to adjust the extent of the map, I'm getting the total bound of the accessibility grid because and the reason is that the network data is bigger than Helsinki, so if I didn't do it, you can try it yourself on your map. It would be very zoomed out because the road network is quite big. But I wanted it to use the extent of the grid data. That's why I set the limit. So one thing is that you will see these coordinates on the X and Y axis, which is nice if you're visualizing a chart. You need to have the values, but for a map, you probably do not need that. And if you want to turn it off, there is a way of doing that. So for X, you can set X ticks to an empty list. So you can also provide values that would appear there, but in this case, I just provide an empty list. Similarly, you can do this for the Y-axis, so it will just turn off the ticks. So if you don't want to see the coordinates on the X and Y axis, you can just turn it off by providing an empty list as the values. So this is the first version of our map. Of course, we're going to continue improving this a bit. The first thing we want to add is adding a legend. So we have all studied a bit of cartography before, so we know legend is one of the map elements that we often need. Otherwise, the colors wouldn't really mean much to the user of the map. So adding a legend to the map is quite simple. All you need to do is provide, I guess we saw this already last week, but you set the parameter legend to true, and that would add a legend to your map automatically. If you want to really customize, so it's automatic. If you want to customize it, then you have to work with it. It's a bit difficult. And there is, if you follow the link to the cartography course, we go through it in detail. So you have to work a bit more. But it usually does a good job creating an automatic legend, which is usually enough. So when you create a legend, then there are a number of parameters you can pass in to semi-automatically customize the legend. So you can, for example, add a title to your legend. You can decide where on the map the legend would appear. But first, let's just run this cell to see what it looks like. So one thing to pay attention to is that, well, here in this example, we are not using schemes, so we are not classifying our data. When the data is not classified, I will zoom out so you see, the legend will be actually a bar. So it's a color bar. So it will look like this. Because you don't have discrete ranges, it just puts it on a scale. So what it means is that if you want to customize things, if you want to look at the documentation, you should remember that, okay, I haven't classified the data, so what I'm seeing is not actually a legend, it's a color bar. It's an object under Matplotlib, so you have to check the documentation of color bar. So there's a link here, and here there are a number of parameters that you can pass in through these legend keywords. So you just pass it in as a dictionary of different values, so you can customize things. For example, if you want to, well, there are a number of things you can change here, but one thing is location. So if you want to place your legend, now it was on the right side. If you want to put it on top, if you think that looks better, then you have to provide a value for location. So location will be set to top. So let's try it here. So there are a number of parameters you can pass in. So location is one of them. So it takes values top, bottom, right, and left. By default, it was on the right, but you can change it. There are a number of things. You can change the orientation of the bar. You can add fractions. You can shrink it. You can make it bigger. You can add some padding. You can do a number of things. So you just pass the right value according to documentation through this legend keywords dictionary. So this is how you pass in the parameters. Yeah. So let's try this again, but this time we are using a scheme. So we are classifying our data. So I'm using quantiles. So let's run this. So now we have used classification. So we have ended up with classes of, we have 5 classes of we have 5 discrete classes. So what happens is that now we actually have a legend. So it's not a bar anymore because we have classes in our data. And now it's a different object under Matplotlib. So if you want to check documentation, this time you should check the documentation of legend. So it's not a color bar anymore. So we have the link here. So for instance, if you want to change the location of the legend, here it's called actually loc. In the color bar, it was called location. Here it's called loc, and it takes more options. So because with that scale bar, you have like 4 main options, the 4 sides. But with a legend, you can have like more options. So it can be like upper right, upper left. So it's called a bit differently. So let's try this now. So now it's by default just placed on upper right of my map. If I want to place it, you can try different values. I'm going to put it on the top left. So this was the way to do it. So in the dictionary, of the legend keywords, you pass a value to loc. And the value was, I will check it again, so I can use upper left. So I'm just going to copy this text. Yeah, so you just pass in the right parameter to loc, and it will put it in the right place. So now I put it in the top left. So when you're making a map, of course, you try to put the legend nicely. So for example, it does not overlap with the contents of your map. So you would adjust the extent of your map and also improve the placement of the legend. But yeah, so you can just put the map legend in different locations. There are also ways of like putting it exactly, like if you want to like by millimeter adjust where to put. In the documentation, it says how you can do that. But yeah, you can also do that. And in the cartography course, we cover the details. But usually this is enough. We have the main locations. You can find a good place for the legend. So now that we have our map, we have added a legend. We have, so let's continue by adding a base map. So there is a lot of controversy around base maps. Some people love them. There are so many different opinions. They're just easy. Some people hate them and like think it's lazy. Like if you're a real cartographer, you should not, base map should not be your first solution. But very often it's needed, especially if you're making, for example, an interactive map. It's nice to have a base map. It gives a lot of content, a lot of context to your map. But anyway, it's nice to know how to do it. For adding a base map, you're going to use a library called Contextily, which allows us to use a very wide range of base maps that are available online. So we know there is Google Maps, there is OSM, there are so many sources we can just use. So with this, it's super easy to do that. Just one important thing, when you are adding, so far you could be in any coordinate system you wanted, anything that suits you, but when you are working with base maps, you have to be careful with coordinate system. And the reason is that almost all internet maps come in the Web Mercator projection. So they come in 3857. So you should project your own data to the same coordinate system if you're using a web map. So that's one thing to remember. So now you know that our data was in 3067. So now that I want to use base map, first thing I'm doing is to take my data, to project my data to 3857, which is Web Mercator. So almost all the well-known base maps, internet maps use the same coordinate system. But of course, if you're not sure, you can always check. So let's just run this cell and take everything to 3857, Web Mercator. Okay, so we already have typed in the part that we have done before. So we create an X object and set everything we have done before. We do some classification, set the transparency level. The only differences are, first, we import the library we need for adding a base map. So the library we need is Contextily, and there are a number of libraries to do this. Again, if you refer to that cartography course or just search online, you will see there are other libraries for doing this, but Contextily is simple and does the job. Yeah, so we import the library. The rest is same. One thing we should do, once you have defined your X object, you should add the base map. And this is how you do it. So from Contextily, the library we just imported, I'm accessing a function called add base map. So where do you want to add the base map? I want to add it to my X objects we just defined. The next thing you need to provide is a source. So it's asking you what base map should be used. And I will show you other ways of doing this, but Contextily has a number of built-in base maps. It's not built-in, it's built-in directory of base maps in the internet. So if you want to access them, you can just use Contextily. From there, you can access the providers. From there, I want to use OpenStreetMap. So if you're unsure how to type things, for example, you need to either remember how OpenStreetMap is spelled, like OSM is capital here, and you should always check the documentation. And then OSM comes with a number of base maps. The one that I want to use here is called Mapnik, is the most familiar OSM base map. The one we see often is Mapnik. Yeah. Yep, sorry. Yeah, so I set the X object we created, and source. For source, I'm using the Contextily's own database of service providers. Let's run this and we can see how we can specify.
Last row as an missing in Contextily, the second row.
Oh, I have a typo. There.
The second row to the right.
Oh, yeah. Yeah, thanks. So let's run this. OK, so now the map is the same as what we created earlier. The only difference is that we have a base map added, and it looks familiar because it's OSM, Mapnik. So yeah, so we already saw, we will continue with the base map, but one information box I've added here is that adjusting zoom level, well, in software it's quite easy. We are just using the zoom in, zoom out button, and we will see in interactive map, of course, we have the zoom in, zoom out function. Here we don't have it, so if you want to specify the extent of your map, then you have to do it using the xlim and y limit. So this is what we already did. But this is one common approach of doing this if you want to automate your process. So instead of like manually setting the xlim that only works for Helsinki, then if you want to produce the same map for, I don't know, Tampere or another city somewhere, then it doesn't work. So one way of doing this is adding some kind of margin like this. So I'm here adding a 20% margin. So whatever map I produce, this way I can just automate the process. It will add 20% margin to the sides and to the top and bottom. So when you are setting the xlim and ylim, then you can just add the margin to it. So does it make sense? Yeah, so this is just one way of course, you can add the margin manually, but this way it's more automatic. So it's 20% of whatever the map you're producing. So this is a good thing to try. But yeah, so if you remember, just what we did here was we accessed the list of providers that come with Contextily. And this is what we get as the output. So if you just try contextily.providers separately, it gives you a list of different providers that you can just use. So now we just use OpenStreetMap.mapnik. You can try different things. So yeah, so we see under OpenStreetMap, we use Mapnik. So there are a number of other options that were available to us. So one thing is that some of them, they have different requirements. Some of them may not be even like free, or they might need some token from you, some API token. So if you try different ones, not all of them might work. So you have to always check the documentation to see if the service is still available. Do you need any other inputs? With some of them, there are some certain requirements. For example, you have to provide an attribution. So they require you to like attribute. So yeah, it's good to check how it works. So this is one way of adding base maps. Another way is by using the XYZ tile URLs. Have you used them before? For example, in QGIS, you can use them. So there are very often these map providers, web map providers, they also provide a URL for connecting to their tiles. So that's also another thing you can try. So actually, here I guess we have the link. I will show you. yeah, so this is an example of an XYZ tile URL. So I just found it by Googling, so Google Maps XYZ URL. So this is another way of adding base maps. So instead of putting this as the source, you can just provide the URL of the service you want. And this you get from the documentation or in internet. Okay. Okay, so now it looks familiar. It's Google Maps on the background. So there are at least two ways of adding a base map. Go to whatever service provider you find, get the URL they provide, put it there as the source, or if it is a service that is already listed under Contextily providers, then you can just access it directly. But yeah, there are two ways of adding base map sources. Yeah, so there's a bit of adjustment. Like I said, we are not going through details of how to make our map beautiful, but of course, when you're producing a map, you should think what you want to show and how you should adjust things so they deliver the message you want to deliver with your map. Like, for example, one thing here is that, okay, the extent is very big. So it's the whole Helsinki area. So it's very zoomed out. So if you want to, and its distances to Helsinki, to Central Railway Station. So depends on who the map is for. If you want to just focus on areas which are around Helsinki center, then you might just set a limit your data. So here we are zooming in on the areas which are a bit closer. So they are within 15 minutes from the Helsinki Central Railway Station. So let's just run this. So now we filtered our data based on that 15 minutes limit, and you see it looks a bit more zoomed in. So depending on what the map is for, you just adjust this thing so you don't overcrowd it. So now we have a finer look at the central area of Helsinki and how the matrix is in that area. Another thing that we can add to our maps, and as I said, it is sometimes required depending on what provider you're using. With OSM, it wasn't specifically required. It automatically adds something here. It's OpenStreetMap contributors. With some of them, you're required to definitely provide a value. But if you want to modify the value or just write something or add attribution, like here, the data we are using is travel time matrix by University of Helsinki. So if you want to give credit to them, which you should if you're, for example, publishing the map somewhere, then once you add the source, well, we already saw this. You set the ax, then you define the source. Then you can pass a text. You can pass a string under attribution. You can just put anything. So you can just say this data is provided by University of Helsinki Digital Geography Lab. So using the attribution parameter, you can just pass in a text that would appear here, travel time data, Digital Geography Lab. So like I said, with some sources, for example, with Mapbox, I think it's required. So if you don't have a value for attribution, you will get an error that you need to have one. But with OSM, it's not required, but it's, of course, recommended. So when you're doing your exercise, of course, your exercise this week is about making maps. So you have a lot of time to play with things, see how you can move things around, how to make them look better, try out different colors, add different base maps, see what works best. But making static maps is fairly simple in Python. So if you don't have questions, let's move on to the second part, which is about creating interactive maps. So as I said, this is one of the major motivations for many people to actually learn programming for doing GIS, to create these kind of interactive maps, which you can easily add to your website, or if you want to publish it very well. One thing we didn't look at, and you actually need it for your exercise, back to a static map. If you want to save your map, as a, well, it's a static map, so you can just export it as an image. So I guess this is something we already saw in the first period. So you can just use PLT. PLT is the library, it's the submodule we imported already from Matplotlib. And from PLT, you can use savefig. And then in here, you can just provide a path to wherever you want to save your file. So I just want to save it in the root. I will call it accessibility grid, just for short. You can specify what format you want, PNG, JPG. Again, in that cartography course, we go through like different file formats and how they're different, like JPG, PNG, and TIFF, and so on. So if you're unsure which one is better for your work, then you can, of course, Google or check the materials from that course. Yeah, then you can add different things. For example, if you want to specify the DPI of the image, if you want to control the quality, then you can just provide a DPI. 300 is a common value you use. Of course, depends on what you want to do. Do you want to print the map, or do you want to just put it on the website? And then other things you can provide. Then I can just use a tight margin for the image, but you don't have to provide this. Yeah, so you can see a PNG file was created. So if you need to export the map, then you can just simply do it using plt.savefig and then export in whatever format you want. Yeah, so that's for static maps. Now we are going to work with interactive maps, and then we are going to export it similar to this one, but the difference is that this interactive map doesn't make sense to export it as an image, because, well, you can't do it, it will appear blank, but also it won't be interactive. So we will export it, but into HTML, and you know probably you can easily host HTML on any website, anywhere, so it's nice if you want to share your map with someone. So has anyone ever made any interactive map using, what have you used for making?
JavaScript, HTML, style file, CSS, other things for that.
Yeah, okay, nice. Has anyone else made interactive map? So if you really want to get into like making interactive map, if this is like your job and you're doing this day and night, then JavaScript is the way to go, because that works very nicely on the web. Yeah, so there are libraries, there are many ways how we can customize the maps a lot. And there are like libraries such as like Leaflet that works with JavaScript, or open layers. So there are a lot of possibilities. But for us that occasionally need to create an interactive map and may not be so comfortable with JavaScript, the good news is that within Python we can create interactive maps. And that is nice, because we are doing our analysis with, the tricky thing about JavaScript is that, well, you're not probably doing your analysis in JavaScript. So you have done it in some software or in Python, and then you have to move to JavaScript to do your visualization. But with Python, the nice thing is that, well, we have been working with GeoPandas. We can do a lot of analysis, and you can stay within the same programming language to produce your interactive map. And there are libraries that allow us to do that. One library that we are going to learn about today is Folium. So Folium is based on Leaflet. Leaflet is a JavaScript library for creating maps. So what Folium does, it just is like a translator in between. So it has a bit of like awkwardness. We will see like things work a bit like differently. And the reason is that behind you don't see, you're just writing Python, but on the back, behind the stage, there is JavaScript happening. So yeah, so the nice thing is that Folium allows us to just stay within Python environment, use GeoPandas, everything that we have been using, and then create a map and benefit from those libraries that are written in JavaScript. So that's the library we are going to use today. There are a number of other libraries, like Plotly is my own favorite. It works very nicely. And in that cartography course I mentioned, we use that a lot, and also Folium again. But yeah, there are a number of libraries, depends on what you need and what's your preference. Yeah, so Folium is a bit complicated. There are a lot of things you can do, and there are different ways of doing things. So if you're really using this like for some for your work, then it's good to check out the documentation. But creating a basic interactive map and adding elements to it is very easy. So let's get it started. So first we are defining the path to the files, of course, where we have our data, but also we are going to later on export our map as an HTML file. So I'm also defining a path to the folder where I want to save the HTML file. Here I have set the HTML mk dir make directory exists OK to true. So this says that if you don't have this and the folder already exists, it just gives you an error that the folder exists. But if you set the exist OK to true, then if the folder exists already, if you run this cell twice, then you don't get an error. If it exists, then it exists. That's why we have this. So let's just run this cell to define our path. Next thing we want to do is to create a very basic interactive map. For that, of course, we start by importing the library we need. And the library we are going to use is Folium. Next thing I'm doing is to create my interactive map object. So a bit similar to the axe object we were making when working with Matplotlib. So I'm going to call it interactive map, but you can name it anything you want. And it is created from folium.map, and M is capital. So this is a basic map without any data added. We are going to continue later on adding data. So one thing you need to provide is to the location, so where the map will be centered. So you can just add coordinates. Again, we are on the web, so this is in Web Mercator coordinate system. So I've already gotten like the coordinates somewhere around Helsinki from internet. So I'm going to just type it in. So you can center the map wherever you want, but I'm going to do it somewhere around Kumpula. Yeah, so location is where the map is centered at when you just load it. Of course, it's interactive, so you can change it. Another thing you can provide is the zoom start. So the start zoom level, of course, it's interactive. The user can change it, but the start zoom level for me, I'm going to use 10. And of course, this is something you can try, see what looks best. I've tried 10, it works good for here. And then if you want to add a scale bar to your map, which may be a good idea, depending on what kind of map you want, you can just set control scale to true, and this will add a scale bar to your map. And then to just add the map to the screen in Jupyter Lab, I'm just going to put the name here. Okay, so as simple as that, you can create an interactive map like this, which is centered somewhere around Helsinki. Of course, you can adjust the coordinates and center it wherever you need. It's OSM by default. We will see how we can change the base map. By default, if you don't provide any source, any base map, it will use OSM mapnik, and it is centered somewhere around Helsinki. And we have a scale bar added at the bottom because we set the control scale to true. So this is very simple. Now we are going to continue and add more features to our base map, to our interactive map. So let's export our map. It doesn't have much content, but let's just see how it works. Saving it is quite easy. What you need to do is to just, well, the map object you have created. From there, you just use .save. And then you decide where you want to save your HTML file. We have already defined HTML directory. And then you pick a name for your map. and the extension, which will be HTML. So now it should be saved. Here we have a HTML folder created. Let's just open the HTML file. In JupyterLab, it asks whether you trust the file. I do trust it, so you can see the HTML was created. So these HTML files can get quite heavy. Like if you have a lot of data, it will be directly written to the HTML file. So if you just share the HTML with someone or put it somewhere, the data is there. So it can get quite heavy unless you work with the HTML yourself. But here we don't have anything added. It's just the base map. Yeah, so this is how we can export it. And this is something you will do in your exercise as well, saving the map as an HTML file. So another thing we can change is the base map. So you may not necessarily want to go with the OSM mapnik, which we have by default in Folium. So I'm going to create the map again, and this time I'm using a different base map. So I recreate the interactive map. You can also copy the code we had from earlier. So I use the same location again. So the only difference here is that I will provide a value for tiles, and that specifies what base map you're using. So here it's called tiles. In the Contextily, in a static map, it was called source. Here it's called tiles. And again, from the documentation, you can see a list of supported base maps, or here you can also, again, use the URL we saw. So if you want to, for example, use Google Maps, you can just use that code. But I'm going to use positron. So this is a common base map used in many online maps. But here there is a link, so you can see a list of map providers and how their name is spelled out in Folium. So I'm using car2 the database positron. Yeah, so it's this simple, a bit minimal base map. So like I said, instead of a name, here you could have provided a URL, XYZ tile URL, and then you could have just used any base map. Yeah, so we didn't change anything. We haven't added any data yet. The only thing we did was to change the base map. Now we are going to add some data. So we start simple. We start by adding a simple single point here. Yeah, so we start again creating the interactive map. The code is typed in. This is what we already had, so we don't need to do it again. Next thing I'm going to do is to manually enter a point. So I start by just adding a point manually. So I will create a marker object, and I give it a name. So I'm going to name it Kumpula, and I'm going to use the coordinates of Kumpula, somewhere from Kumpula, and add it to my map. So from Folium, I use a marker object. And for defining a marker, you need to provide the location coordinates. (6204). So this is somewhere in Kumpula. 24.962. The next thing I'm going to add is a tooltip. So when I hover on the point, it would show me a pop-up, some kind of message, and you can put any text you want. So I want to just write Kumpula campus. Now, of course, another thing you need to define is the icon. So how do you want the map, how do you want the marker to be shown on the map? And again, under Folium, you have to create a Folium icon object or define one. So Folium.icon. Then in Folium, there's a link here you can follow. There are a number of built-in icons that you can just use for your visualization. Somewhere in the documentation. So what I'm going to use is an icon that is called OK sign. What you can do is to specify the color of the sign, and we will see how it looks like when we run this. I'm going to make it green. And the icon shape, I want to use the one that is built in. In the cartography course, again, we see this can be any image. So if you want to use your own icon, you can just have the file somewhere there and use a path to the file. But in the cartography course, there are examples of that. For now, we are just going to use one of the built-in icons, so we don't need to download any image or use anything. So the next thing we should remember to do is to add it actually to our map. We defined it now. We have a marker, but it's not added to our map. So I'm going to add Kumpula to my interactive map. So I use add_2. And then I add it to my interactive map. So this was one of the built-in markers that we used. I set the color to green. There are a number of colors you can choose from. And then when I hover over the marker, I see this message, Kumpula campus. This is the string I provided here. So you could have written anything. So if you want to add markers, it's as simple as this. This is good depending on what you want to do. If you just have a bunch of points you want to visualize, this works well. But very often we have a larger data you want to visualize. You have a set of points. You have a GeoPanda data. You have a geodata frame that you want to visualize. And now we see how we can add a layer of points to our map. So for that, we are going to use a data set that is familiar. We created it actually together on week 3. It's the addresses that we geocoded on week 3. So now we are going to use that same geo package we exported last time, 2 weeks ago, and add it to our map. So what I'm going to do now is to import GeoPandas and load the data. Yeah, this is my data. It's giving me a warning that I haven't specified the layers, but I know this is the right layer, so it's okay. So next thing I'm going to do is to recreate the interactive map and add the layer to it. So instead of adding the point manually by typing in the coordinates, I'm just going to use this geodata frame and add it to my map. So the beginning is the same as what we have done before. We create a Folium object, Folium map, and then we specify whatever we need to specify. The next thing I'm going to do is to add an address layer. So addresses layer. So one thing is that, as I said, this is using JavaScript under the hood. So the data format that it actually works with, because it's using leaflet, and leaflet works with GeoJSON. It's a geospatial data format that works well on the map. So if you're working with JavaScript, you have some experience, GeoJSON is common. So leaflet uses GeoJSON, but Folium allows you to use your GeoPanda geodata frame but it converts it to JSON. So that's why this code looks like this. So from Folium, I create features. And I use GeoJSON because, like I said, because Folium is using Leaflet, and Leaflet uses GeoJSON. But the good thing is that you don't need to convert this manually. Folium will take care of that. All you need to do is just provide your geodata frame. And this was our geodata frame. It was called addresses. And then you want to give a name to your layer. And I'm going to now write public transport stops. And again, remember to add your layer to the map, to the interactive map. So I'm going to add this. To the interactive map. So it works very quickly. Now you have a map with all those points that we had geocoded on week 3 added to the map. So this is not required, like it's optional, providing a name for layer, but of course it's recommended, and it's especially important if you have multiple layers added to your map. And for example, if you want to have this control layer option, then it's important. So yeah, so let's try one thing. Let's edit our code up here. So from Folium, I can add a layer control. And remember to always add it to your map. So I'm going to add it to my interactive map. So if I run this, so if you have this line added, Folium layer control, it's going to add this for you. So it gives you the option to choose layers. So if you have multiple layers of data, then you can just use that to choose the right layer. So this name you see here, public transport stops, is what you provided here. So that's why it's important to have the name. Even if it's optional, it's good to have it because it's the name. And if you have a layer control, the name would appear here. Then you can just switch between different layers. So another thing we can add to our map and can be useful in an interactive map is a pop-up with a bunch of information that might be useful for the user of the map. So let's go through the code. The code is already typed in, so we don't need to type here. So again, this is repetition. I'm creating the interactive map again and zooming it, centering it on the same place, a bit more zoomed in than last time. Then I'm creating a pop-up object. Again, this is a GeoJSON pop-up defined under Folium. Then you provide the fields that you want to show in the pop-up. So the value in the pop-up, what would it be? I want to show the addresses. And the column, this is the column in my geodata frame. It was called address. So if you just go back up here where we printed the head, where was it? Yeah, so you see this is the name of the column, actually address. Let me rename it. Yeah, so it's the name of the column that we want to use. And then you can provide an alias, so it's a nickname. So if the name of your column is ugly, it's typed badly, it's very often the case, like you have some short name in your column names. If you want to give it a nickname, then you can just provide a value here. So I'm going to write address with a capital. That looks better. Then localize true. this is optional, but if you set localize true, it will know where the map is loaded from. So if there are like some localization, like in terms of, because the map is coming from the web, so if the name of the places can appear in the local language, or if the signs are different, if you set localize true, it will localize for the person who is loading the map. So if someone is opening the map from Poland or I don't know, Germany or somewhere, it will be localized. So that's an optional thing you can choose. Then labels, if you set labels to true, well, let's run this so we see the output, then it's easier to explain. So now if you click on the map, on the marker, you see there is a pop-up. If you have label true, the name of the column will appear here. If you don't put it, then it will just show the contents of that column. So this is what label does. I've set it to true, so I also see the name of the column, and it's using the nickname I've provided. And adding a bit of a styling. And this is just easiest to get it from the documentations and other examples you have worked with. And then the same we have done before, addresses layer. So we are loading the address and then adding it to the map. And this is the output we get. So if you want to get a pop-up, it's fairly easy using Folium. So next thing we want to do is add a polygon layer. So for adding a polygon, you can do it in different ways. So one way is just do it similar to point. So with point, we just created a GeoJSON object, and we added it to the map. So if you want to just add your polygon in the same way, you can just do it the same way. Just load the data, and that works fine. But here we want to do something different. We are going to try and create a choropleth map. And with Folium, this choropleth map works quite well. So it is quite automated. It adds a bit of like visualization to your map, and it looks quite good usually. But let's load our data. So we are going to work with some data set that we have worked before. It's the population grid we worked with, I guess, in the second week. And we are going to get it from WFS. So let's load the data. And this is how it looks like. We have columns with values of population by different age groups and different genders. So now let's clean up our data a bit. This is something we have done many times. So we are going to rename it to English. The code is typed in, so let's just run it. So we only kept 3 of the columns. We only kept the population data, the geometry, and the index. And we renamed the population to English, so it's easier for all of us. So when you're creating a choropleth map, so one important thing that can be very confusing if you have not done this before, and it's one of those weirdnesses of Folium because of the fact that it uses leaflet under the hood, is that it needs you to provide an ID field that is a string. So it needs an index column that is a string. And that's, if you don't know, it's not difficult to make. We will just create it. But you need to know, because when we are working with geodata frame, by default, we have this index column that is an integer. But when you are working with Folium, it expects you to have a column, an ID column that is string. So the first thing we are going to do is to create that string column. So we are just copying the values of our index, just converted to string. So we don't have to do anything difficult. Another thing about Folium that can be confusing is that Folium assumes that you have 2 separate data files. One of them is your geospatial, like it's your coordinates, it's the geodata. The other one is the attribute table. So that's what it assumes. So very often we have a vector data like we have now, and it has columns. So attribute data is in our geospatial data. But in Folium, it assumes that you have a table with values, then you have coordinates. So what it always does, it joins the 2 tables based on that ID field that I just mentioned. So in our case, everything is in one file, so I don't need to do that join. But because Folium expects me to do the join, what I'm going to do just to get away with it is just join the table with itself, so it doesn't affect my data, to just get past the requirement. But that's the assumption. So you have a table, you have a geodata, they have an ID field in common, and it does the join and does the visualization. So this is what we are doing. So first I'm going to create that column that is string. So I'm going to just create a new column in my population grid data and call it ID. So you can create whatever value you want, but I'm just going to use the value of the index. The only difference is that I'm going to just convert it to string, because that's what is required by this library for choropleth map. So I'm just reading the index values from population grid and converting them to string and writing them into this new column called ID. I have a typo here. Yeah. Okay, so now we should have a new column added with index values, but in a string format instead of integer. So now I'm going to add this to my map. Part of the code is typed in, so the beginning is what we have done already many times today. The second thing I'm going to do now is to add that layer to my choropleth map. So I'm going to create population grid underscore layer. And I'm going to define it as a Folium choropleth. So as I said, you could have just added it as a normal vector data like GeoJSON, but this time we're trying the choropleth map. So these are a bit difficult to remember sometimes. So first parameter, one of the parameters you need to provide is the geodata. Again, remember I said it thinks that you have two separate data. One is your geodata with coordinates, one is a table. So what is the geodata? It's a population grid. We don't have two data sets in our case. So I'm just going to provide population grid. Then it asks you for data. So what is the attribute data? In our case, it's all in one place. So I'm just going to use population grid again. If you had a separate attribute table, then it would have done the join for you. Then what columns do you want to have added here? So I want the ID field that we just created, and of course population, which we use for visualization. And then what is the field in your data that you're going to do the join based on? Remember, we are doing a join between them. And the parameter to provide is key on. And you have to use feature.id. So ID is the name of the column we just created. Remember, it's the index values just converted to a string. I've added feature here because this is how it is in GeoJSON format. So the column name goes under feature. And because this is working with GeoJSON under the hood, I'm accessing the ID from feature. So just remember that this is how you access that column that you created for doing the join based on. Of course, here it's a bit useless because everything was in one place, but this is what the library expects from you. So again, remember to add this to your map. So I'm just going to copy this so I don't have to type it. Then add to. typo here. Yeah, so now my map is created. So you can see it automatically adds some visualization. It's like it improves visual. So compared to just adding it as a vector data where you have to specify how things look like, if you create it as a corpus map, it will automatically add some features to your map. So if you're in a hurry to create a decent looking map, corpus might be good for you. But of course, you may want to customize it yourself a bit. But let's continue with this corpus map and improve some of the visuals. Like I don't like this color, or I don't like it that these outlines are so thick. We don't need the outlines. So let's continue and improve the looks of our map. So the code is typed in already. Let's go through it and see what we have. So everything is almost the same until here. Then I'm adding more bins for the colors. So it's the number of bins that you see here. So it classifies it for the visualization. So I'm just increasing the number of bins to 9. Again, you may want to try different numbers. I've done this before. 9 looked okay. Then a fill color. This is a fill color that we saw before. It's a range from yellow to red. You can choose any color that you think looks better. I don't want the grids to be shown, the outline, so I will just set the line with weight to 0. You can add a name for your legend. It will appear as a text under the legend. So population 2020 is the data we are using. And then we add it to the map, and that's it. So let's just run this. We get a new map that looks slightly better than what we had. So it does a lot of things automatically for you, but still you have the possibility of improving how things look like, change the colors and styling a bit. Yeah.
How is it handling the projection this time? Is it already like pre-projected to the webpack card, or even if it's roughly 6 or 8 for that?
Yeah.
Okay, we imported it as like population grid as W84.
Yeah. Yeah.
Then when I put it on the Folium map, it already
Yeah, it takes care of it automatically, yeah. Yeah, so Folium does a lot of things, like, so it's an easy solution. Of course, some people prefer other libraries. You want to be more in control, but if you want a quick map, it does a number of things for you.
Does it have to be in this projection, or could you do this with any kind of projection?
You can specify, but if you have a base map, then you should, that defines what coordinate system you should be in. Yeah, so next thing we want to do, now this map already looks good. Yeah, so we have also highlight true. Highlight does this, so if you just go over the grid, it highlights it. So if you set it to false, or if you just don't provide any value, it will be off. So then we want to add a tooltip, so when you hover on the features, you can see something. So one thing we can do with Folium, and this is a bit like you should see examples and check the documentation, but you can create a style function. So if you want to improve how things look like, you should define this style function like this one, and then it returns a dictionary of different values that you want. So if you want to really customize this, it's good to check the documentation because it's hard to remember. But yeah, now we are improving things. We are defining a style function. We are setting the color to transparent. Yeah, so the reason why we are doing this is that for adding the choropleth, like with the other one, when we added it as a vector, when we use it as JSON, so there was an option to just add a tooltip. Here, we don't have the option to add the tooltip to the choropleth. So what we are doing is to do a trick. So we add the map on. We are adding the layer twice. So we are adding the grid twice. The second time, I'm making it invisible. So I'm putting the transparency to max. but I'm using the second time for adding a tooltip. So let's look at the code and see how that works. So this is what I'm doing. So I'm creating the tooltip based on the population data. So let's just run this. So the interactive map, we are using the same interactive map we created earlier. So it's the choropleth map. We are not redefining it here. What we are doing here is we are adding this population data again as a GeoJSON, but this time we are setting it to transparent. The reason is that choropleth does not support tooltip, but I want to have a tooltip. So what I do, I add that layer again. So it's a trick, like very often when you're doing programming, you need to do these things. So I add the population grid again, this time as a feature GeoJSON, the thing we did at the very beginning. And this time, this one supports tooltip. We saw it earlier. But I don't want this to appear on top of my choropleth map. So what I'm doing, I'm setting it to transparent. Both the color of the outline and the fill color, I'm setting to transparent. So I'm doing this trick to get that tooltip from this. So I define the tooltip and I add it to my map. So let's run this. And you get this tooltip. So if you hover over it, you get the information about population. So did you understand what we did in the last step? Yeah. So choropleth map doesn't natively support tooltip, but GeoJSON does. So what I did, I wanted to add it as GeoJSON, but I didn't want to mess my map having two layers on top of each other. So the GeoJSON I just made transparent, but I'm using it to get the tooltips. Yeah. And let's save our map here. At the very end, we have one cell with the code. So let's just save it as choropleth with tooltip. It will be saved in our HTML directory. So there are a few links. As I said, there are a number of libraries that help you visualize things. And of course, it depends on what you're used to. For example, Folium works in a certain way. And it might be a bit strange if you haven't worked with it so much. But then you get used to it. So some people prefer other libraries. Like I personally like Matplotlib better. Many people work with Bokeh. It's also a very popular library. Mapbox GL works very nicely with Jupyter, GeoViews, and there are many libraries. So yeah, so you should check the documentation. As I said, some of these are covered in this cartography course. In this cartography course, we use Plotly a lot, and also again Folium. Yeah, and that's it for today. Do you have any questions? Yeah, and if not, that's it. See you next week. This week the exercise is about, of course, making maps. So you will make a static map, you make a interactive map, and then, yeah. So cartography is not a part of like course, so we didn't really go through how to choose colors. But of course, you have all studied GIS, geography before, so you have some sense of how to make a good map. So when you're doing your exercise, try to make the map as nice as it looks. That's not the main thing, but try to make it decent map. Yeah, so see you next week.